Yeah, it's really exciting to have this opportunity to share what we've been doing at our coding club. So we're always trying to reach new people. And I really hope that our resources will be helpful to some of you today. So I'll just start by introducing a bit the club, how it came about, and what we do and what our motivation is. And then I'll show you what resources we have, especially for landscape ecologists and spatial ecologists. And I'll give you a little demo of some coding activity you can do as part of our tutorials. So. Okay, so the club started 4 years ago when some undergraduate students in the ecological sciences and environmental sciences program at the University of Edinburgh realized that they were not quite getting the quantitative skills they wanted or needed. So there's this kind of gap currently with what's being taught in the curriculum that you can kind of get through your degree without not doing much statistics at all, and what employers are now expecting, and more everyone wants a data scientist. So they wanted to kind of teach themselves these skills. And the model arose from also not wanting to make it a stressful environment. So I don't know how experienced everyone is today. I'm sure you're at different ranges. Maybe you're here because you've never done any computer programming and you want to learn. Maybe you already have some experiences, but you want to improve. And I think most of us can often face that code fear and that sort of anxiety of having to face a blank screen and do stuff. And often we come into ecology not being particularly computer or math people, so it's easy to think, oh, I don't have the brains for it, and it's stressful. And if you do that as part of the course that's assessed, it's even more stressful. So the model was to have just a group that gets together once a week, and people help each other, and we bring snacks, and it's just very, very friendly, very informal, and we get through stuff. And what I really liked the best, I've been a tutor from the start, but there's really no hierarchy. So you have a few people helping through the session, but they change from week to week depending on your strengths. So sometimes I go as a student when I don't know the topic, and sometimes I'm there to help people. And we have undergraduate students helping PhDs. You have professors turning up sometimes saying that they want to catch up with what their students are doing. So it's really a good level playing field for everyone, and we're just there to learn. So it's become a really nice, positive community. But since you're all spread out everywhere, and not a lot of you are in Edinburgh, I think probably what you'll be more interested in is our online resources. So everything that we do as part of our workshops, we put online in our tutorials section. So you can go and access those. They're free, they're all there, and you can use and adapt them as you want. So over the years, we've grown this really big online community. So we have people from pretty much everywhere in the world accessing our tutorials. Only last week, a student chapter from the Galapagos Islands got in touch saying they wanted to translate them in Spanish and use them. And we really love seeing that. That's what we're there for. And we really like seeing other universities start their own clubs. And seems to be a model that works really well. So if you go to our website and look at our tutorials, we have some spanning lots of topics. I should say that we're mostly using the R language, so some of you are probably familiar with that. It seems to be becoming the norm in environmental science. It's a really kind of user-friendly language. It's very readable. It's very good for reproducible research and for sharing and collaborating. So most of our tutorials do that. They span a complete beginner, how to import data, how to download the software, to how to do various data manipulation and analysis tasks, up to very advanced things, so complex mixed effect models and Bayesian statistics. So there's something for everyone. We have a few other languages as well. So if you're interested in Python, we have a really popular tutorial on the Google Earth engine as well. So we're trying to expand on that. It always depends on who joins the club and what skills they have to bring. And if I won't open the website, but that's what a tutorial looks like. So it's a mix of short paragraphs and chunks of code. So it really talks you through the analysis. The tutorials usually have a little story, so they have a few objectives and they give you a data set, usually real life data set, useful and kind of relevant to environmental science. And then they will explain the objectives and they will explain each chunk. And we're not mathematical people, so we keep the text really low level and simple. So it's usually we get told it's quite readable and accessible. It's not too dry. So you can just go through the code, copy the chunks in your software and run them and just try to understand. We really focus on understanding what each bit does. So I'll give an example in a bit, actually. You're probably all mostly interested in spatial data. So these are the kind of tutorials we offer. You can learn to make protein maps to extract biodiversity data from online databases and to model the abundance of a species. And in a few minutes, I'll give an example of using remote sensing data as well. Before I do that, I just thought I would take the opportunity to plug our online course that Chloe mentioned. So we launched that in January. So it's an online course. It's completely free. And it's just using some of our most popular tutorials that we've revised and updated, and we've put them into a kind of streamlined format that makes it a bit more logical. Instead of just doing piecemeal tutorials, you have a more logical progression if you don't really know where to start. So we've tried to design that as the most flexible course you can have and still call it a course. So it runs continuously. You can join whenever you want. There's no deadline for finishing. So you do the tutorials you want when you want. And we've made it as a kind of choose your own adventure thing. So we've designed 3 streams that we think are kind of a beginner, intermediate, and advanced one, but you're free to mix and match across them if you want. So our most popular at the moment by far is the beginner one. So people who just want to learn to use R and develop good habits early, so learn to write good code and to import data and run simple analyses. But nothing stops you if you do data manipulation 1 and you thought it went down well and you're interested in doing more, or you need to do more for your thesis or something, then you can go and do data manipulation 2 in the next stream. And so you can just flit across and do what you want. And at the end, you can request a certificate for the tutorials you've done. So you don't have to do everything in one stream, and you can still get recognition. So we think that's really useful for students who want something on their CV, or if you have professional development built into your job, you can kind of just evidence what you've done. And we think that's why it's been quite popular so far. So we've had over 1,500 sign-ups since January, and it's mostly students, as we would expect. But we've been really happy to see that a lot of non-academic professionals have also signed up. So Scottish Natural Heritage actually got in touch a few weeks ago to say that the climate change group was using our tutorials to refresh their skills during lockdown, and they have a little coffee break every week to talk about it. So that's really nice to see, and I think having that flexibility makes it really easy to work around a day job or your studies, whatever. Another good thing about it is that we're really focusing, they're written by ecologists for ecologists, so we're trying to use fun data set and make it realistic in terms of what you would do in your daily data analysis tasks. So the course has 3 challenges at the end, 1 for each stream, and they all use open data that are freely available. So one challenge is around the abundance of red squirrels versus grey squirrels from the Scottish Wildlife Trust. There's one on native woodland from the Forestry Commission Forest Survey, and there's one on the breeding success of seabirds from CEH data. So it's really the kind of things you probably do in your jobs, and it makes it just a lot more fun to learn while doing something that you can see the end point. So Vanessa and Chloe have asked me to give you just a little sample of what you might come across in one of our tutorials. I'm just going to try to figure out how to change my screen. Give me a second. Right, okay. I think probably you see my screen now. So I will say, if you've never used R before, don't panic, because I will show you in 5 minutes what you would do in an hour-long tutorial. I just want to give you an impression of the kind of the little story arc you might come across in one of our tutorials, and the skills you might get from that. So this tutorial was written by actually one of those students who started as a quite insecure, I don't think she would mind me saying, a student who came to every workshop, and for 2 years she was always there and she was very determined, and now she's teaching in the club, she's developing content, and she's starting a PhD. So she's done really well, and this tutorial is about spatial analysis, so it's about using satellite data. We'll import a satellite picture from Sentinel data from around Loch Day in Scotland. And we'll look at the vegetation index. So we'll create a measure of greenness, and we'll try to classify that and infer land use based on this. So if you're not familiar with R, this is my script with all the commands in it. This I've already run before. It's just setting up where the files are and what packages we need to access the functions we want. Here I'm reading in a raster, so I see it pop up in my environment, and I can preview it as well. And if you're familiar with satellite data, you probably know they have different bands, so they record images at different wavelengths. So this is just a preview that pops up in my viewer with all the different bands. There's green and blue and infrared, etc. So if you're familiar with vegetation indices, they're a measure of greenness that we can calculate using the difference between some of these bands. So the most common one is NDVI, and it uses the near infrared and the red bands. And the difference between that gives you a measure of how green the landscape is. So usually that's related to vegetation. Here there's a function. That's something we have a whole tutorial dedicated to creating your own functions, because they're really useful when there's something you need to do quite often. You can write your own custom function, and that's a lot easier to customize after. So here I'm telling it, you will take one image and 2 bands that I give you, and you will extract the band from the whole raster stack, do the difference between them and divide that by the sum of them, and you will return this new image. So here, if I run it, I tell it to take my image that we've imported, the band 8, you would know that from the metadata in your image, but the band 8 is near infrared, band 4 is infrared, and it does a calculation. So I see that something's been created here, and I can plot it, and it will appear in my viewer. So here we have high values that represent high levels of greenness. The benefit of that function is that if I was like, oh no, actually that wasn't the band I wanted, then you can just, instead of having to do a calculation based on all the bands again, you just change the number in your function, you run it again, and you have a new result. So now we've somehow created a function that identifies water instead, it seems. So I'll just go back to our real NDVI plot. You can also decide to view the distribution of those values, so you see them as they are in the landscape now, but you might be interested in the statistical distribution if you want to do statistical analyses later. So you can plot that as well with a histogram. And what I really like from my tutorials is that they're full of little snippets that are really reusable. So you might need that code for something completely different. And then I tend to just bookmark those that I find useful, or create a little code library, and I just go and steal from those whenever I need them. So now that we've identified where the green spots are in the landscape, we might be interested in masking out parts of the landscape that are definitely not vegetation. So this lake in the middle, we kind of know it's a lake, the values are really low. So here we're using the reclassify function to take our image and we say everything that's below 0.4, we want to erase that, and we'll plot it again. And now we have a new raster that looks a lot clearer, parts of it masked out that correspond to the water or man-made surfaces. So that's another really useful thing that comes up pretty often if you work with raster data. Often you have to reclassify it to some more meaningful bins. And finally, the tutorial goes through quite advanced stuff. So over the course of an hour, if you choose to do it, you go from learning how to import an image to actually perform an unsupervised classification on it. So what you're doing is that you're giving it those values that we've created, and you say, try to aggregate them into some bins that would represent things you might observe on the ground, sort of land use categories. So here in the function, we're telling it to create 10 different bins, and the algorithm will just go through the image and try to identify clusters of pixels that are similar. And once it's run, it just creates kind of a long string of values, and you put that back in your image, which is what I'm doing now. And then you can plot it again. And it's identified, now the values are 1 to 10. So they belong to some different groups. You can see that the lake would be, I've got everyone on my histogram, so I can't see. So the lake would be value 6, for instance, and then you have some really value 10 would probably some of the dark vegetation. And to make that a bit clearer, usually you would probably do some more fancy tests, but we can just plot them and start to explore these relationships. So here I'm telling my viewer to create 2 panels, and I will plot the image. That's kind of a real view. It's using the red, the green, and the blue bands to create kind of a real-life bird's view image. And then next to it, we'll plot our new classification. And then you can start to investigate relationships like that. So it's kind of an exploratory analysis, and then you would go and try to refine that and really associate land use classes. But you can see the trees, the really dark green, they would come up as number 10, etc. So that was a bit fast, but that's the kind of thing you can do in our tutorials. As I said, they're better explained than that, so you have really a little paragraph for each chunk of code. But I hope that can demonstrate that you can gain really useful and transferable skills. So you might not be interested in the vegetation around Loch Tay, but probably you do similar things in your study areas. You might need to learn to play with raster data to extract specific bands of these data, to reclassify values, perform calculations on them. So that's all stuff that's in our tutorials, and we have a lot more, as I said, if you're interested in doing statistical modeling, different forms of classification or mixed effect models, or if you want to play with vector data as well and make maps, we have all of that. So if you have any questions, or I hope that was useful and there's something in there for you, but if there's more topics you want to learn about that we don't have, get in touch. If you want to contribute something, get in touch. We always love to have new tutorials. And we're also always there to answer questions. If you decide to join the course and you have a problem with one of the challenges, we're always happy to give a hint as well. So I will leave it at that, and thanks for listening. And if you have any questions,